You need to watch this if you struggle with repetitive tasks and endless to-do lists. Let me tell you a story about the magic of automation. Once upon a time, in a world where time was precious, efficiency became the hero. Automation stepped in, streamlining tasks and saving valuable hours. Imagine a world where repetitive tasks are handled effortlessly. This freed up time for creativity and innovation. Enter shell scripting, a powerful ally in this journey. Automation became not just a tool, but a necessity. It transformed the way we worked, boosting productivity and ensuring consistent results. And that, my friends, is the power of automation. Once upon a time in the vast realm of computing, there was a magical tool called the shell. This shell was a gateway, a command line interface that allowed wizards, also known as users, to communicate with their operating systems. Among the many shells in this enchanted land, 3 stood out: Bash, Ish, and Fish. Bash was the most popular, known for its compatibility and powerful features. Ish, on the other hand, was celebrated for its scripting prowess and customization options. And then there was Fish, the friendliest of them all, designed to be intuitive and easy to use. Each shell had its own unique charm and abilities. But in our journey, we'll focus on Bash, the most beloved shell of all. Imagine a world where your computer does all the heavy lifting for you. That's the magic of shell scripting, a skill that can transform how you work with computers. Let's dive into some real-life stories where shell scripting has made a huge impact. Meet Alex, a system administrator who once spent hours managing user accounts and monitoring systems. With shell scripting, Alex now automates these tasks, freeing up time for more critical work. Imagine provisioning new user accounts with a single command or setting up automated backups for critical system files. Shell scripting has empowered Alex to manage complex systems efficiently and effectively. Then there's Jamie, a software developer who used to dread the repetitive tasks of compiling code and running tests. With shell scripting, Jamie has automated these processes, making development faster and less error-prone. This automation speeds up the development process and reduces the likelihood of errors. But it's not just for the tech-savvy. Even everyday computer users can benefit. Think about automating tasks like resizing multiple images or converting files between different formats. Shell scripting can help you organize files based on specific criteria, saving you time and effort. So, whether you're a system admin, a developer, or just someone looking to make life easier, shell scripting is your secret weapon. Once upon a time in the world of computers, there was a magical tool called shell scripting. Imagine you had a list of chores to do every day. Shell scripting was like a helpful assistant that did these chores for you. It was a series of magical spells written in a text file. The shell would read these spells and bring them to life, giving you the power to control your computer's actions. And just like that, you could boost your productivity with a few simple commands. Welcome to Section 2, the anatomy of a shell script. Imagine you're about to write your first shell script. Let's break down its structure together. Every great story has a beginning, and for shell scripts, it starts with a special line called the shebang. This magical line tells the operating system which interpreter to use for our script's journey. For our bash scripts, the shebang line is #bin/bash. Right after the shebang, we dive into the heart of the script, the commands we want to execute. These commands can range from simple file operations to complex system tasks. For instance, you might use the cp command to copy files or the mv command to move or rename them, and mkdir to create new directories. To make our script more readable, we can sprinkle in some comments. Comments are like notes to ourselves, ignored by the shell but invaluable for human understanding. In bash scripts, we add comments by starting a line with the hash symbol. Picture this, a simple script to create a directory named backup and copy all your important files from the documents directory into it. This script would use the mkdir command to create the directory and the cp command to copy the files, and just like that, you've crafted your first shell script. Welcome to Section 3, Unleashing the Power of Variables. Imagine you're a wizard, and variables are your magic wands in the world of shell scripting. These wands or variables hold the power to store data, making your scripts dynamic and reusable. In the magical land of Bash, you create a variable by simply assigning a value to a name like, this my variable. Hello world. Once you've cast your spell and defined a variable, you can summon its value by prefixing the variable name with a $sign, $. For instance, to reveal the value of the my_variable, you would use the command echo $my_variable. These magical containers can hold different types of data, including numbers, strings, and even the output of commands. This versatility allows you to perform various operations on variables, such as concatenation, arithmetic operations, and string manipulation. By wielding variables effectively, you can craft more efficient and flexible shell scripts. Picture this. You want to write a script that performs the same task on multiple files. Instead of hard-coding the file names in your script, you could use a variable to store the file name and then iterate over a list of files performing the task on each one, and just like that, you've harnessed the true power of variables. Once upon a time in the world of coding, there was a magical tool called the shell script. Our journey begins with understanding the basics. Imagine a shell script as a scroll of commands, each one executed in order like a wizard casting spells. These commands can be as simple as moving files or as complex as interacting with databases. Much like a wizard's spells can range from lighting a candle to summoning a storm. And just like every spellbook starts with a magical incantation, every shell script begins with a shebang line such as #bin/bash to invoke the right interpreter. Let's dive into the world of shell syntax. Imagine shell syntax as the language of your computer's command line. Just like in any language, whitespace in shell scripting separates words, or in this case, commands and arguments. And then there are special characters. For instance, the hash symbol is like a note to yourself, marking comments. Mastering these elements is like learning the secret code to efficient scripting. Welcome to Section 3, Data Under Control. Today, we're diving into the world of variables and data types. Imagine variables as magical containers in your shell scripting journey. They hold the data you need to make your scripts come alive. In the Bash world, creating a variable is as simple as casting a spell with the equals operator. Picture this. You type name equals Alice, and just like that, you've created a variable. To reveal the magic inside, use a $sign. Type echo $name and watch the value appear. Bash is versatile, letting you store numbers, strings, and even command outputs in these magical containers. Once upon a time in the world of shell scripting, there were decision points known as conditional statements. These magical tools helped scripts make decisions. The mighty if statement would check conditions and, if true, execute commands. But what if the condition wasn't met? That's where else came in, offering an alternative path. And then there was elif, a hero for handling multiple conditions, executing the first true block it found. If none were true, the else block would take over, ensuring the script always had a path to follow. Welcome to Section 2, where we dive into the magic of repetition with loops in shell scripting. Imagine you have a task that you need to do over and over again. Shell scripting can take that burden off your shoulders. By using loops, you can tell your script to repeat actions, making your workflow smooth and efficient. Bash scripting provides 3 types of loops: for, while, and until, each suited for different tasks. For loops are like a checklist, going through each item one by one, while loops keep going as long as a condition is true, and until loops, they keep working until a specific condition is met. It's like having a personal assistant that never gets tired. Welcome to Section 3, where we dive into the art of choosing the right path by nesting control structures for complex logic. Picture this. You have a script that needs to process a bunch of files, each requiring different actions based on their type. To handle this, we can nest control structures, embedding conditionals within loops, creating a powerful decision-making process. Imagine a for loop that iterates over each file, and within it, an if statement checks the file type. Based on the file type, different commands are executed, making your script versatile and dynamic. But remember, effective nesting requires clear and readable code. Proper indentation visually separates nested blocks, reflecting the logical structure and making it easier to follow. However, be cautious. Excessive nesting can make your code hard to understand and maintain. Strive for simplicity and clarity, avoiding unnecessary nesting whenever possible. If your code becomes too complex, consider refactoring it into separate functions to keep things manageable. Nesting control structures offers great flexibility but demands careful management to avoid pitfalls. Keep your code organized and well commented to maintain readability and ease of maintenance. Use nesting wisely to handle complex logic efficiently, and you'll master the art of scripting like a pro. Once upon a time in the land of shell scripting, there was a powerful tool called functions. Functions were like magical spells that helped coders avoid repeating themselves, making their scripts shorter and less prone to errors. Imagine a function as a self-contained spell, performing a specific task whenever invoked. Wise coders would define these spells to break their scripts into manageable units. These magical functions promoted reusability and consistency across the land. With a single change to a function, the magic would spread everywhere it was called. Functions brought modularity to scripts, making them easier to understand and debug. Each function could be tested on its own, ensuring the magic worked perfectly. This modular approach made it easier for teams to collaborate on scripting projects. Functions encapsulated logic, bringing order and organization to the scripts. They streamlined the code, reducing redundancy and making it more efficient. Functions made scripts more maintainable and efficient, a true blessing for coders. Embrace the magic of functions for cleaner, more effective scripting. Functions were essential for managing complex scripts, turning chaos into order. So, leverage the power of functions to enhance your scripting skills and become a master coder. Welcome to the second part of our journey, crafting reusable code blocks. Today we're diving into the art of defining your own functions. Imagine you're a wizard, and functions are your spells. Defining a function in Bash is like crafting your own magic. Start with the magic word, function, followed by your spell's name and some curly braces. Inside those curly braces you place your magical code. For instance, let's create a spell called greet_user that says, hello user. Just like naming your potions, function names follow the same rules as variable names. Choose names that clearly describe what your spell does. To cast your spell, simply type its name followed by parentheses. For example, greet_user. The shell will execute your spell and then return to the script. Make sure to define your spells before you try to cast them. This ensures the shell knows about your spell before you use it. Proper placement of your spells prevents any magical mishaps. Functions help you encapsulate your code, making your scripts as organized as a wizard's spellbook. Imagine you're in a relay race, passing the baton to your teammate. In the world of shell scripting, this baton is like function arguments and return values. These elements make your functions incredibly versatile. To pass arguments to a function, simply write them after the function name. For example, consider the function greet_user, username $1, echo, hello, $username. You access these arguments using positional parameters like $1, $2, and so on. Return values, on the other hand, send data back to the script. Use the return keyword to send numeric values back. Capture these return values with the $variable. Arguments and return values make your functions flexible and powerful. They enable your functions to perform specific actions or calculations. Functions can also return exit statuses to indicate success or errors. By using arguments and return values, you can create dynamic functions. This enhances your scripts with versatile, reusable functions. Mastering function arguments and return values will elevate your scripting to new heights. Once upon a time in the world of coding, there was a simple yet powerful tool, the backup script. Our story begins with the creation of a backup script for the important _documents directory. The first step was to define the source and destination directories. To make each backup unique, the date command was used to create timestamps. With a simple cpr command, the source directory was copied to the backup location. It was crucial to ensure that all files and subdirectories were copied. To wrap it up, a completion message was added to the script. This message could be displayed on the terminal or logged for future reference. With a single command, backups could now be automated. This script simplified the backup process immensely. Regular backups of important documents were now ensured, and so file operations were automated for maximum efficiency, making life easier for everyone. Once upon a time, in the world of servers and systems, there was a need to keep an eye on disk space. Enter our hero, the basic system monitoring script. Our story begins with a simple task: monitoring disk space usage. The df command was our script's trusty sidekick, gathering all the disk space information, but raw data wasn't enough. Our hero had to parse the df output to extract the crucial used percentages. To be vigilant, the script set a threshold for disk space usage, and whenever usage exceeded this threshold, an alert was triggered. The script could display a message or even send an email notification to the system administrator. To ensure constant vigilance, the script was scheduled to run periodically using cron jobs. This way, disk space usage was monitored proactively. Preventing issues caused by low disk space became a breeze. The script even took on the responsibility of automating system monitoring for critical applications, and with automated alerts, timely action was always ensured. And so, our hero, the basic system monitoring script, kept the system running smoothly ever after. Welcome to Chapter 18, where we dive into the art of archiving and managing log files. Imagine your log files piling up, taking up precious space. What if you could manage them effortlessly? Let's start by focusing on a specific log directory. Picture yourself using the find command to locate those older log files. Now you can archive these files with zip or tar, just like a pro. Next, move your archived files to a designated directory, keeping things tidy. And don't forget to delete the original log files to free up space. You can even automate this entire process with a script. Imagine a clean, organized log directory, free from clutter. Preserve those older logs for future reference, neatly archived. Efficiently manage your log files with automation and keep your system running smoothly. Let me take you on a journey through the scripting minefield. Here are some common pitfalls to avoid. Imagine you're scripting away and suddenly things go wrong. Avoiding common mistakes can make your scripting journey smoother. Picture this. You forget to quote your variables, and now your script can't handle spaces. Always quote your variables. Unquoted variables can lead to unexpected command interpretations, causing chaos in your script. Enclose your variables within double quotes to keep things under control. Now imagine your script encounters an error. Handle it gracefully with proper error handling. Always check command exit statuses using the $variable and implement error handling mechanisms. Use absolute paths or change the working directory to avoid getting lost. Incorrect working directories can cause issues. Make sure to set them correctly. Never assume the script's working directory. It can lead to unexpected results. Ensure your scripts run correctly from any directory for maximum portability. Follow these best practices to avoid common pitfalls and enhance your scripting skills. By avoiding these mistakes, you'll become a scripting pro in no time. Happy scripting! Once upon a time in the world of shell scripting, there were a few golden rules that every coder swore by. These best practices were the secret to writing clean and efficient scripts. Our story begins with the importance of following best practices for efficient scripting. The first rule in our tale is to always start scripts with the shebang line, #bin bash. This magical line tells the system which interpreter to use. By specifying the interpreter, you ensure your script runs smoothly no matter where it's executed. Next, our hero uses comments to explain the script's purpose. These little notes are like breadcrumbs guiding anyone who reads the script. Comments are essential for maintainability, and proper indentation makes the code a joy to read. Indenting code blocks within loops and conditionals is like organizing a library. It makes everything easier to find. Consistent indentation enhances the logical flow of the script, making it easier to follow. A well-structured script reduces cognitive load, allowing you to focus on the task at hand. Proper indentation also makes debugging a breeze, saving you time and frustration. By following these best practices, you can write clean, efficient scripts that stand the test of time. And so, with these guidelines, you too can elevate your scripting game and become a master of shell scripting. Happy coding! Welcome to Chapter 21, where we dive into the world of debugging with our trusty companion. Tools and techniques for troubleshooting shell scripts. Imagine you're deep into coding and suddenly errors pop up. Debugging becomes your best friend. Picture this. You use the echo command to reveal the hidden values of your variables. You start tracking the data flow, pinpointing exactly where things go wrong. Then, you switch to trace mode with bash xscript.she comma watching every step unfold. Each command and its arguments are displayed before execution, helping you understand the sequence. You use setu to catch any unset variables, preventing unexpected behavior. Undefined variables are highlighted and you swiftly fix them. With set-e, your script exits on command failure, halting execution to avoid further issues. The script halts, and you address the errors head-on. Armed with these tools and techniques, you conquer scripting hurdles like a pro. Once upon a time, in the world of computing, there was a powerful tool called shell scripting. This tool had the magic to boost productivity and unlock the true potential of systems. With it, one could automate mundane tasks and manage complex operations effortlessly. The journey to mastering this tool required practice and perseverance. Starting with small tasks, one could gradually tackle more complex challenges. Along the way, guidance from online resources became invaluable. Exploring advanced concepts and tools opened new horizons. A deeper understanding of operating systems led to efficient problem-solving skills. Managing and manipulating data became a breeze. And so, with shell scripting, endless possibilities were unlocked, leading to countless successes. Don't forget to subscribe, like, comment, and share for more amazing content.